Hey everyone, today we are solving LeetCode problem number 1143, longest common subsequence. It is another very important dynamic programming question and has been asked in many companies like Amazon, Google, Yahoo, Apple, Microsoft, Uber, Adobe, etc. Okay, let's have a look at the problem statement. Here, in this question, we will be given two strings, text1 and text2, and we have to return the length of longest common subsequence. And if there is no common subsequence, return 0. Okay. So two string will be given to us and we have to return a subsequence length which is common among both of the string and having longest length. So if you see in this example, we have A. If we check A, C, E, AC is the longest common subsequence. AE is also subsequence. AC is also subsequence of both of this string, but ACE is the longest. So we have to return the length of this subsequence. So 3 will be our answer in this case. Okay, now let's try to have a look on the approaches. Here, as string 1 is A, B, C, D, E. This is the first string, or you can say text 1 given to us, and we have text 2 as well, which I will say string 2. It is ACE. These are the two strings and we have to return the maximum common subsequence, or you can say longest common subsequence among these two strings. Okay, so if you have a look on the bigger problem, that this is our first string, this is our second string. If we start solving this problem from index 0, let's say for the first string I'm tracking the index using I variable. For the second string, I'm tracking the index using j variable. Initially, I is 0, j is 0. That is, we have to compare first character of S1 and the first character of S2. First character of S1 is A, first character of S2 is also A. If both the characters are same, it means that this is one possibility that we like consider this element in our longest common subsequence, or maybe any candidate for longest common subsequence. It means that we have one element for sure. Otherwise, what we can check is we can check rest of the common subsequence from B, C, D, E and from second string C, E. This is one possibility. And what is the other possibility if character at S1 and S2 are not same? Okay, let's say in our first case, these two characters are same. If I have a look on the further cases where we have B, C, D, E, and C, E. So these are our two string now. And here the problem is almost same, that we have to check longest common subsequent from these two strings. And our main problem was also this one, longest common subsequence. So this is what we will call a subproblem. So let's have a look on this subproblem. Here the first character is not same. It means either we will not consider this element or we will not consider this element. Let's say if we have a look at the first case. So here we will, if we are not considering this B, we will consider C, D, E and CE. Either is its LCS of this subproblem will be equal to LCS of this problem, or LCS of, if we consider B, B, C, D, E and not considering C, LCS of this problem, and the maximum of this we will take because we want like the longest one. Okay, so maximum of this subproblem result and this subproblem result will be our answer for this subproblem. Okay, so ultimately we got three test cases if both of the character in the starting are same. In that case, this is our candidate. If both the character are not same, in that case the maximum of these two are our candidate. Okay, so now let's try to have a look on the recursion for that. B C A B C D E. A, B, C, D, E, and the other one was A, C, E. Okay, so this is also my approach 1, that trying to solve using recursion. I am using recursion because this bigger subproblem can be broken down into subproblems. So this is my problem given to me. I am going to break this problem into subproblems, and later on in the end I will write some terminating cases where I will stop my recursion and then calculate the result. Okay, so in this case I have two possibility. The first one is, let's say I'm taking I as a variable to store the index of first string and j variable to store the index of second string. If s1 of I equal to s2 of j, this is my string 1 and this is my string 2. If this is the case, our candidate is 1 plus, let's call it a solve function. So solve function of s1 passing s2, incrementing I, incrementing j. So this is one case. And in the second case, if that is not same, or you can directly say else case. In the else case, it is maximum of solution s1, s2, considering element from second string. So incrementing I, either this or this complete string and this one. Solution of s1, s2, solution of s1, s2, I, and j plus 1. Considering one, like ignoring one element from first string and ignoring one element like starting element from second string. So maximum of these two can also be our candidate. So this is the case. If that is if we can have only these two cases, and in these two cases this is our answer. Either we are going to return this, or we are going to return this. And what is going to be our terminating case? If I is equal to s1 dot length, or j is equal to s2 dot length, that we have finished any one of string. In that case, we are going to return 0. That is no long common subsequence possible in this case. So this is going to be our terminating case. So we have our terminating case and our subproblem recursion. So in this way, we can approach this problem using recursion. But here we have to see that in our solution function, I am passing first string, second string, I index of the first string on the first string, and j index on the second string. We can memorize our solution using over these variables. So let's say after some time I is equal to 3, j is equal to 2. These kind of problems can be repeated while solving our recursion, because in the starting I is equal to 0, j is equal to 0. After some time, let's say we are ignoring first element from first string, it will be 1 comma 0 and 2 comma 0 and 3 comma 0. Or maybe after some time 2 comma 0, 2 comma 1. Or let's say we are skipping the first element, it is 1 comma 1, after that 2 comma 1. In this way there will be some overlapping subproblems. Previously we saw that this is our bigger problem, and bigger problem is being broken down into subproblems, and these subproblems can be overlap over these values of I and j. It means we have overlapping subproblems. As we have overlapping subproblems, so we can use memorization with our recursion. Recursion with memorization, or you can say DP, which is top down DP. Firstly, we are getting the bigger problem, picking the bigger problem, and breaking the bigger problem into smaller problems, and in the end reaching to the terminating case where any of the string is of where I or j is reaching to the string length. Okay, so this overlapping subproblem we can solve using recursion with memorization, or you can say top down DP. And what we have to memorize in our solution function, apart from string 1 and string 2, these two are constant. I'm passing index to store index to represent my first string and index for my second string. These ing are variable, so I can store among these values. And in the problem statement, if you see that I and j value will go from 1 to 1000. So here I will write recursion with memorization, where I will memorize in a variable dp of 1000, where index will go from 1 to 1000, or what was that? Yeah, right, it was 1000. So I'm taking an array size 1001. 1001. It can be of integer size, integer type. So this array I can use for my memorization. Okay, I hope this first approach of DP clear to you, where I have used top-down DP, overlapping subproblem we solved using recursion with memorization. Let me first write the code for that, and after that we will move to our approach 2, where we will do bottom-up approach using tabulation. Okay, now let's write code for our top-down approach. Here in this example, while having dry run on the example, we found out that this is a recursive problem where we can solve it using recursion, and we can memorize it later on over the values of our parameters we are passing to a solution function. So let me first write a helper function where I will pass first string, second string. I need solution where I'm considering a top-down approach. It means I'm picking a bigger problem. It means starting from zero index till last for first string, and starting with zero index till last for first string. And in the end, let me also directly return from this solution function. Okay, let me write let me write the implementation of this helper function. Private int solution string. Let's call the first string as string 1 and second string as string 2, int I and int j. Edge case we will see later on. And we have two possibility, whether the character at ij is same or different. If it is same, then it means one we can add to our candidate answer. If s1 dot character at I equal to s2 dot character at j, else it is not same. If both the character are same, we will return 1 plus solution of s1 s2 I plus 1 j plus 1. Otherwise we have to return math.max. Currently I'm only writing recursion. We will do memorization later on if we get TLE. Math.maximum. First call would be s1 s2 I plus 1 and j, ignoring one element from first string, and now ignoring one element from second string, I j plus 1. Okay, this is our processing. Our edge case would be if I is equal to s1 dot length, or j is equal to s2 dot length. In that case, our LCS value is 0. Okay, if I try to submit our sample test cases, yeah, it is working fine because we have written a recursion. And if I submit the problem, we should get TLE because we are not memorizing our subproblems. Okay, we got TLE. Okay, now let's try to memorize it. It's going exponential in this case. And if I write a DP array, integer array, double array, DP, what should be the size of this DP? Let me just take it to the maximum size, which is 1000. DP is equal to new integer 1001, 1001 because I want 1000 as a index in it. Okay, now that is fine. Here we have to check. First of all, we have to store. Mm, we will store before returning return result, and this result we will store in against ij, and this result can be this value or this value. So let me take a separate variable integer result equal to 0, or result can be this, or result can be math dot maximum result comma this value. We have three cases: either the characters are same or characters are not same, ignoring first character of first string or first character of second string. So ultimately we have our result, and this we can store against the values of I and j. And before processing, I will check, do I need to process it or not? If dp of I j is not equal to null, it means there is already some value we have pre-computed, and we are directly going to return that, avoiding these calls. Let me submit of sample test cases again. Compilation error. Here it should be a semicolon. Working fine of sample test cases. If I submit the problem, we are making the solution to n square, m into n. Okay, it was submitted successfully. Hope you understood this approach. Now let's try to understand the bottom-up approach as well. Okay, now let's have a look on our second approach, which is bottom-up approach of dynamic programming. Previously, I solved this problem using recursion with memorization, where I was tackling the bigger problem and then moving to the smaller problems and then reaching the terminating case and then returning from recursion, and as well as I was doing the memorization. Here in this problem, we will firstly see the smaller problems and then moving to the bigger problem. Let's say our string 1 was A, B, C, D, E, and string 2 was A, C, E. First of all, I will see the very small problem, which is I'm considering no element from each string. In that case, LCS is 0. If I considering only one element from both string, and before that there is also some small problems, that is one element from first string, zero element from second string, or zero element from first string, one element from second string. In this way, I'm approaching this problem. So here what we usually do is we do the tabulation to store our answer. For tabulation, like we have to use 2D DP in this case because we have two string. Let me draw the table A, B, C, D, E, and let's say no element from this string, no element from second string A, C, E. First of all, we have to see very small case, which is no element from first string and no element from second string. In this case, 0 is the answer. That's understood. And what is the second problem? Let's take this from first string and this from second string. That is, from first string we are considering A, from second string we are taking null. In this case, it is also 0 because second string is 0. So it will be 0 for all of these cases. For this and this one, it is 0. For this and this one, it is 0. For ABCD and empty string, it is 0. For ABCDE and empty string, it is 0. Now let's have a look on the next table, where from this string we will consider this, and from this string first of all we will consider this and this and this and so on. Okay, if I'm considering A from second string and empty string from first string, it is 0. And if I'm considering this and this, if both the characters are same, we are taking one element from here, or if ignore this element, we will get empty from first string, empty from second string. For that, result is 0. So either it should be 1. And here let's go to this shell. For the first string, for this string I'm considering A. For this string I'm considering AB. If I consider A, B and A, I will see whether A and B are same. If A or B are not same, it means we are either skipping this character or we are skipping this character. If we are skipping B, if we are skipping B, it means we have to find result from this string to this string, that is this value. Or if I am skipping A, it means I have to take value from this cell, that is, okay, let me show you. We have AB from first string and A from second string. B and A are not same. It means either we are taking result of AB and empty string or A and A, like this. Here AB and empty string are having 0 at LCS, A and A are having 1 as LCS. So here it will be 1. The maximum of these two value. From AC it is not same. It means maximum of these two. 1 will be taken here. A and D. A and D is not same. We will take maximum of these two shell. From left side, from up side. A and E is also not same. We will take values from these two. That is 1. We will check for AC and this row. AC with empty is also already 0 and AC with A is C and A are not same. It means either the answer coming from here or coming from here. That is, either we are skipping C or we are skipping A. The maximum value is 1. So AC and A is having LCS as 1. B and C are not same. It means the maximum of these two, which is 1. AC and ABC, here C and C are same. It means 1 plus, ignoring C from both, that is 1. 1 plus 1 is equal to 2. 2 is LCS for AB, C and AC. Okay, now C, D are not same. Taking maximum value from here, which is 2. AC and ABCDE, that is 2 coming from here. For this it is 0. Taking this complete string, and A, which is 1, and E and B is not same. Maximum of these two, which is 1. E and C is not same. Maximum of these two, which is 2. E and D is not same. Maximum of these two, which is 2. E and E is same. It means this 2 plus 1, which is 3. Okay, so 3 is the answer of this whole string and this whole string. So we are going from smaller problem, which was here, till the biggest problem, which is here. So this was our bottom-up approach, where we are using 2D array as our to store our tabulation method. An array should be of size m plus 1 and n plus 1, taking one column for empty string as well. Okay, now let's try to code this approach as well. Here, what is the time and space complexity? It is m into n. Time complexity, and space is also m into n to store our tabulation. Okay, so let's code this approach. Here for bottom-up approach, I am taking a dp size array, 2D array of m plus 1 into n plus 1. Let's capture m and m, and m is equal to text1 dot length, and n is equal to text2 dot length. And I'm taking a dp array new int of m plus 1 and n plus 1. I'm storing answer from 0 0 to m into n, and m into n will be my answer. Return dp of m and dp of n in the end. Here I have to do the processing from the table we draw, that if any one of the string is empty, our answer is going to be 0. So first row and first column is 0. That is already pre-initialized in this 2D array. So I can start from I equal to 1, I less than equal to m, I plus 1, and for int j equal to 1, j less than equal to n, j plus plus. Here we have two cases, and in this dp array I am I'm taking a row as 0 for ACE. I'm taking the first for ACE, the first row or column is 0, that is no character. Second one is one character. Third one is two character, and fourth one is all three characters. So row index or column index minus one would be the corresponding character in the string. So let me first match the ith and jth character in the string. If text1 dot character at I minus 1, because I am also considering empty string, is equal to text 1 2 dot character at j minus 1. If those two characters are same, my dp of ij is equal to 1 plus the final result without considering these two characters, that is dp of I minus 1 and dp of j minus 1. And what if these two characters are not same? dp of I j is equal to math dot maximum. Maximum of what two value? dp of I minus 1 j and dp of I and j minus 1, considering one ignoring one element from first string or one element from second string. So in this way we are filling up our dp array, and in the end we are returning dp of m into n, which will store the LCS of both of the string. Let me run over sample test cases. Okay, I already have this method. Let me call it top down, and this one is our bottom up. Sample test cases are passed, so let me submit the problem. It is submitted successfully, and it is way too faster than the recursion with memorization approach, but that approach is very important to understand the basic concepts of our dynamic programming. And here no recursion stack is involved, and our time and space complexity is m into n. Okay, I hope you understood both of these approaches. Thank you guys. Bye bye.